Okay, please listen, and we will start in a minute. I would like any one of you to confirm that we have a clear sound. Okay, thank you for confirmation. So let us proceed. Again, this is your professor. I am Dr. AP Zantua, and we will today talk about module number 8. So there are 3 sub-modules under this. So let's start with number 1, more on methods of design. So methods of design, and we'll start with the objective of this course. So this course is a professional course and provides fundamental concepts, principles, and theories under structural analysis and design of steel elements in a structure. So there are 8 main topics under this course, and we are now actually on the second major topic. So about the specification, loads, and methods of design. So we have another sub-topics under this second major topic, and right now we are on module number 8. So let's proceed with the definitions. So let's have some definition of what is a design strength. So a design strength is the product of the nominal strength and a resistance factor. So let's take note of this. So meaning to say, we have a nominal strength and we have a resistance factor, and multiply those two together, and the result would be our design strength. So next we have what? Factored load. So the factored load is now the product of the nominal load and a load factor. Okay, so load, when we are talking of load, we have a nominal load and a load factor. So multiplying those two together, we have the result, factored load. So I need to also monitor my okay. So next definition, what is limit state? It is a condition when a structure becomes unfit for service and is judged either to be no longer useful for its desired or designed function. That is serviceability limit, because there is a sense of performance to it. It is not performing the way we want it to be, or to be unsafe. Brutally unsafe, meaning it already reached its strength limit state. So those two are the definition, the meaning of limit states. Strength design. It is so design strength is different from strength design. So strength design is a method of proportioning structural members such that computed forces produced in the members by the factored loads do not exceed the member design strength. Okay. So in other words, we have what? Finding out the correct dimension, correct size, okay? For a particular size, for example, what is the dimension? So we want to proportion the dimension, okay? So also it is called load and resistance factor design, in short LRFD. Okay, so load resistance factor design. Okay. Next, what is allowable stress design? Allowable stress design, or ASD. Okay. In short, ASD. It is a method of proportioning structural members such that elastically computed stresses, okay, elastic, okay. So we are on elastic region. Take note. Okay, when we are using strength design, we are actually on the plastic region, because we will use what? Ultimate. We will use the ultimate value. Okay, so elastic point is very far from the ultimate value when we are talking of steel. Okay, and we are designing steel right now. So the region wherein we are designing under allowable stress design is elastic. No? Computed stresses produced in the members by nominal loads do not exceed specified allowable stresses. Okay, that is the method. Okay, also proportioning the structural members, because we are what? Designing. So strength design, allowable design are both design methods. So they try to what? Find out the correct ratio and proportion of the dimension. Okay. It is also called working stress design, or WSD. By the way, if at any given time you might have question, comments, please use our comment box below, and you would be happy to answer your queries. Okay. So that's why from time to time I will look after the comment box. I will read the comment box if ever there are inquiries. Okay, so now we are now going to describe methods of design. So there are two acceptable methods for designing structural steel according to the code, according to AISC. Okay? So AISC 360, and we are now on the update 2016. Okay? So that is my latest copy. So I do not have the latest one, maybe 2019 or 2020 or 2021, 2022. Okay. So my latest copy was a free one, so I have 2016. Okay. So there are two. Number one, LRFD. So load and resistance factor design. And number two, allowable stress design. So some authors say that it is what? Allowable stress design. Okay? So this author is using the word allowable strength design. So actually, strength design is LRFD, and stress design or allowable stress design. So allowable stress design is ASD. So, and this is usual. This is usual. This is not the only author that use this terminology. Anyway, we are referring without confusion to a certain method which is called ASD. They are defining it sometimes allowable stress design, sometimes allowable strength design, but because of the word allowable, it is different from strength design. Okay, take note of that. So you may get confused when there are problem solving or question about strength design and allowable strength design. Okay. So those are the two methods. Let's go to the next slide. Limit state. Again, so in layman's term, a limit state is a condition at which a structure or part of a structure ceases to perform its intended function or the desired function or the designed function. Okay? So when our designed part, designed structure is not actually performing what we want it to do, therefore that is the condition where it already reached the limit state. Okay, so in short, a condition just before the collapse of the structure. Okay, so because when we want it to perform something and it is not doing its job, so most probably it would collapse because it is now having great amount of, for example, load. Okay, so our design purpose is not being performed by the member, by the structural element. Okay? So that is what we mean by limit state. So it is just a condition just before the collapse of the structure. Okay? So there are two categories of limit states. So, and all of these are very important. So number one, major category is what we call strength limit state or ultimate limit state. So either one is being used. So either strength limit state, usually used is ultimate limit state. That means strength limit state. Okay. Why? Because if you can observe, if you use strength limit state, in short, that is SLS. And take note of the number 2, it is also called SLS. So there is no what? Distinction about the two. That's why strength limit state is actually called ultimate limit state. So when we talk of ultimate limit state, it is the limit state. It is the condition that deals with the safety of structure. We want to take note. We want to observe. We want to check if our structure would give us the safety design function. Okay, so we have what? Certain range. Okay, so and outside of that range now, it will collapse, and the boundary between just before the collapse and the maximum strength or ultimate limit, that is what we mean by limit state. Okay, so that is the ultimate point. So the ultimate point is describing a single point. Okay, while the number 2 serviceability limit state is the limit state which deals with the durability of structure. So take note, all limit states must be prevented. And therefore, as an engineer designing a structure, we would like to design in consideration of each of the limit states. So, meaning we will talk about what are the limit states for number 1 and what are the limit states for number 2. So there are plenty of them. Okay, but in this course we have a short and limited time for one semester. We will focus on the principle and concept on strength limit state or ultimate limit state. So what are the types of ultimate limit state or strength limit states? So these are the type that define load carrying capacity of the element or structure. Like what? Yielding. Okay, so we want to design our structure in consideration of the yield characteristic. Letter B, fracture. Okay. Letter C, buckling. And letter D, fatigue. And letter E, gross rigid body motion. So those are the samples, actually the different ultimate limit states. Okay, we want to design. Okay, design against. We want to design against excessive yielding. We don't want it to happen. We want to design against fracture. We don't want it to happen. Okay, we want to design against buckling. We don't want buckling to happen. We don't want fatigue to happen. We don't want instability to happen. Gross rigid body motion. Okay? So those are 5 different types of ultimate limit state, ULS. What about SLS or serviceability limit state? We can design the system against deflection, number 1, letter A. Letter B, against cracking. Okay, letter C, against slipping. Okay, we already know what do we mean by deflection. Okay, so how much the beam would deflect, how much our element would deflect. Okay, B, cracking. Cracking is the what? Physical phenomena of having what? Broken. So there are what? Separation of group of particles. Okay, slipping. Slip. So slipping. Meaning, for example, one type of slipping is, for example, our reinforcement slips. Slip with the concrete. Okay, that is sleeping. So when we are talking of what? Reinforced concrete. So because this topic is not only for steel design but all the design, okay? General. This is a general topic that is applicable to all other design like timber design, reinforced concrete design, pre-stress design, but steel design. So, okay. So number 4 or letter D, vibration. Okay, so we would like to design against vibration. There are several locations with heavy vibration. Therefore, case-to-case basis, there is no two location with exactly the same vibration load. So therefore, we want to design against it. And letter E, design against deterioration. So those are the things that we need to design. So there are at least 5 different design approach, design target consideration with regards to ULS, and another 5 target design consideration with regards to SLS. So if you really want to design it holistically, you have to design 10. There are 10 design computation consideration. Okay. However, we will tackle mostly what? In this course, we'll tackle mostly yielding, buckling, I think. So we will heavily focus on yielding and buckling. Okay. Because of time constraints. Okay. And maybe we cannot do anything about this. Or sometimes, probably deflection. So if we are allowed by time, okay, by our limited time, okay. So those are to be expected from this course. So please be reminded of those things. Now let us proceed to the challenge question. So question number 8. For materials engineering review, cement mortar for curb and gutter shall be used within blank minutes and preparation. So how many minutes? Okay. Must the cement mortar for curb and gutter shall be used after preparation. Okay. So A, 30 minutes, B, 45 minutes, C, 60 minutes, D, 90 minutes. So you can have your answer on the comment box below. So again, this is Dr. AP Preaching Engineering for Nation Building. Okay, so we will see you next module. Thank you.